In this video, we are going to use normal approximation to Wilcoxon sign rank test. So I'm going to start from this step. We did this in last video. So now the idea is this test statistic is normal distributed with some mean and variance. Okay. So now the condition is sample size is more than 50. So if sample size more than 50, then we can assume the test statistic is normal distributed with mean mu t and variance sigma t square. And the formula for mu t is going to be n time n plus 1 divided by 4, and for the variance it's going to be n time n plus 1 time 2n plus 1 divided by 24. Okay, so let's calculate the mu t. So n is 10. So mu t is going to be 10 times 11 divided by 4. That's going to be what? That's going to be 27.5. And let's calculate the variance. That's going to be 96.25. Okay, so even though sample size is 10, we need more than 50. Let's try to use the method and see how it works. So you can use it later when sample size more than 50. So now the idea is we have to calculate the test statistic. So we use z, which is t minus mu t divided by sigma t. So this is going to be what is t? T is from here, 15 minus 27.5 divided by square root of 96.25, because I need standard deviation, not the variance. So I get 15 minus 27.5 divided by second square root 96.25 and get negative 1.2741. Okay. So now the condition is, if you read the slides, it says what? It says if you are using left tail or right tail test, then reject H naught if z is less than negative z alpha. If you are doing the differences test, then reject H naught if z is less than negative z alpha divided by 2. Okay, so let's calculate z alpha. So my alpha is 0.05, and this is two-tail test. So I calculate z alpha. So here is 0 because this is standard normal. Z alpha, Z mean standard normal. So this side you have 0.025 because which is basically alpha divided by 2, and I want this value z alpha over 2. So that's going to be what? That's going to be inverse norm if you use calculator, 0.975, and that's going to be it's going to be 1.96. Okay, so now we reject H naught if z is less than negative z alpha over 2. So what is my statistics? Convert to the standardized score. It's going to be negative 1.2741, and this value is going to be negative 1.96. So is this true? It's not true. Okay, so negative 1.2741 is more than negative 1.96. So we fail to reject H naught. So that's how you use the normal approximation. For this problem, actually n is 10. It should be more than 50.